There is another question here which has ambiguity in the mind of even teachers. Learner तो क्या कहेगा? At what temperature will the root mean square speed of oxygen become just sufficient for escaping from the Earth's atmosphere? Mass of oxygen molecule given. Mass of oxygen molecule of O2 molecule is equal to 2.76 10 to the power minus 26 kg, and Kb, Boltzmann constant, is 1.38 10 to the power minus 23 joule per Kelvin. So what are you asked? At what temperature the root mean square speed of oxygen molecule will be sufficient to escape from Earth's surface? You know, escape speed from Earth's surface. Escape speed, topic of gravitational field from Earth is 11.2 into 10 to the power 3 meter per second. So the question is that at what temperature speed of the mean square speed of oxygen molecule is this. You are given Boltzmann constant. We know the oxygen molecule is a diatomic gas, and kinetic energy per particle, kinetic energy per molecule is equal to F by 2 kBT. Here people are not treating this topic like this. They simply write it is a particle and kinetic energy per particle 3 by 2 kBT. It is the general concept in the brain of teachers and learners. But we have learned lot of things about gases, their degree of freedom. And degree of freedom for F is the degree of freedom. Degree of freedom for oxygen molecule 5. So 5 by 2 kBT is equal to half mv square. So you are at this temperature, you are given this velocity, you are given this mass. So 2 cancel. T here equal to mass 2.76 10 to the power minus 26, velocity this 11.2 10 to the power 3 square upon 5 kb 1.38 10 to the power minus 23. So then how to solve? Very simple. 10 to the power 6 plus or this. So 20 power. So T here left here like this. 2.76 into 11.2 square into 10 to the power 20 minus upon, you can multiply directly 5 8 are 44, 5 15 or 4 19 1 or 5 1 5 6 I mean, this is the multiplication into 10 to the power minus 23. 2.76. 11.2 square. 11.2 into 11.2 upon 6.9 10 to the power 3. If we multiply and divide, the answer will come out 5.016. I have done it separately. 5.016 times power 4 Kelvin. Actually, the book with me has given other answer. 8.3 10 to the power 4. They have assumed 3 by 2 kT. So remember, whenever you are doing numerical problems on kinetic energy per particle or per molecule, take care of the degree of freedom. For monatomic, degree of freedom is 3, for diatomic is 5, for triatomic is 6. So here is the problem. Now, simple question है यहाँ पर, and this question has been asked in NEET 2018 में ये क्वेश्चन पूछेगा नीट में। और अगर आपने कहीं 3/2 भी तो आपका एक नंबर गया होगा, एक क्वेश्चन खराब हो गया है ना। इसके लिए मैं आपको स्पेशली बता रहा हूँ कि प्लीज इंटरनल एनर्जी पर मोल भी लिखते ना वो, दैट मस्ट बी रिटन लाइक दिस F/2RT। जनरली हमारे ब्रेन में फंसा हुआ है 3/2RT। In NCERT book there is a question here. My old friends were very much worried कि सर ये तो होता ही आंसर ही मैच करता है। वो डिग्री ऑफ फ्रीडम का झगड़ा था उस क्वेश्चन में भी। तो प्लीज टेक केयर ऑफ दिस while treating gases and their kinetic energy. Remember that kinetic energy per particle per freedom is half kBT. Now he said here a real gas behave like ideal gas. यहाँ भी एक प्रॉब्लम है, what is real gas and what is perfect gas or ideal gas? Perfect gas or ideal gas is same, एक ही चीज है। Real gas by perfect gas or ideal gas follows all the basic laws of gases like Boyle's law, Charles' law, Avogadro's law, etc. We say like this: real gas, a gas in general, when you cool it, get liquefied. When you further cool, get solidified. In this consideration, we have taken that molecules have no appreciable force of attraction or repulsion, but molecules have force of attraction, so that may be very weak, not appreciable. But when gas is compressed, molecule come close to this or compress or pass, and so then due to this fact the gas does not behave like gas. And ideal gas is that which always behave like gas, does not get solidified, does not get liquefied. So here the question there, a real gas behave like ideal gas if its pressure and temperature are both high. Pressure and temperature both high. B option, pressure temperature both low. C, pressure high temperature low. Pressure low temperature high. I have told you while telling one question in some video, at high temperature, please note this very carefully. At high temperature and low pressure, every gas behaves a perfect gas. The ideal gas. The word has been taken from the concept. An ideal man does not break the rules, though he never speak lie, does not tell lie, whatever the condition, that person is good ideal. Similarly, a gas which remain gas in every condition, but in every condition, no gas is ideal. Only the gas behave like ideal at high temperature and low pressure. Remember this thing. Now, there is a little imaginary question. An ideal gas expanding such that Pt square is constant K. Suppose an ideal gas is expanding in such a manner that Pt square is constant. The coefficient of volume expansion, of volume expansion is number 1 upon the option है A, 1 upon T, B, 2 upon T, C, 3 upon T, and D, 4 upon T. So these are the options. So first of all, we have to understand the meaning of coefficient volume expansion. We have learnt delta V is equal to gamma V delta T. So you are asked this thing, gamma, what is gamma? Delta V upon V into delta T. ये गामा निकालना है आपने यहां से. ठीक है बच्चों. तो we know we are given this condition. We are given this condition, and further we know that Pv is equal to nRT and the number of moles. From here, P is equal to nRT upon V. Putting this value here in this equation, nRT upon V into T square equal to K. Or K into V is equal to nRT cube. I told we need dV over V into delta T. So differentiating with respect to capital T. तो K into dV over dt is equal to nr into 3 T square और K dV equal to 3nr into T into T. Again nRT is equal to PV. और dt तो है समझ dt nRT PV और K into dV over dt equal to 3 PV into T. और dV over V into dt dV upon dt है ना इक्वल टू 3p p upon k but k is pt square 3p t upon pt square तो p cancel so this is called coefficient of volume expansion equal to 3 by t. So this is the option here correct. ना भाई 3 upon t. I hope you have got my point. So please learn question very properly. This question has been asked JE 2008. JEE 2008. Or even in classes I have seen with my friends, we always avoid. I have faced many problems with friends. Actually, everybody is not equally sincere. People are just passing time. They go in class after passing long time and miss, they go in the class very late. One of my friends says, the teacher is that who goes in class after just running without wasting time. He is the teacher. Now there is another good question has been asked in AIEEE. AIEEE in 2011 क्या है? 3 perfect gases at temperature T1, T2, T3 are mixed. Three perfect gases at temperature T1, T2, T3 are mixed in a container. The masses of molecules M1, M2, M3, 2, 3, and number of molecules N1, N2, N3. Three perfect gases are temperature T1, T2, T3 having mass of molecule M1, M2, number of molecules N1, N2, N3 are mixed. If in mixing there occur no loss of energy, if during mixing there occur no loss of energy, then temperature of mixture, options given हैं वो सारे A N1 square T1 square plus N2 square T2 square plus N3 square T3 square upon N1 T1 plus N2 T2 plus N2 N3 T3 and so on. So many options are there. B option given, let me give T1 plus T2 plus T3 plus T3 upon 3. C option N1 T1 plus N2 T2 plus N3 T3 upon N1 plus N2 plus N3. And C of B option is there also. N1 T square T1 square plus N2 T2 square plus N3 T3 square upon N1 T1 plus N2 T2 plus N3 T3. So after seeing so many options, you get confused. Ideal gases at temperature T1, T2, T3 are mixed. So there will be no loss of molecules, there will be no loss of energy. So at final temperature T, you know, kinetic energy per molecule of gas. या यूँ कह लीजिए यस किनेटिक एनर्जी पर मोलिक्यूल ऑफ गैस इज F/2 kBT per molecule. There are n molecules, so total energy will be total energy. If there are n molecules per molecule, so N1 into F/2 kBT. जो गैस टेम्परेचर T1 पर है इसके नंबर ऑफ मॉलिक्यूल्स जितने हैं उसकी टोटल एनर्जी होगी. इफ टोटल एनर्जी लेट फाइनल टेम्परेचर बी T, if temperature of mixture Bt, then F/2 kB N1 plus N2 plus N3 into T will be the total mixture, and it is the sum of the energy of 3 F/2 kBT N1 T1 plus F/2 kBT kB into N2 T2 plus F/2 kB N3 T3. So this get cancelled everywhere, or T equal to left here only N1 T1 plus N2 T2 plus N3 T3 upon N1 plus N2 plus N3. So option C is correct. Dear student, what are you doing? Is extra effort. If you want to be some different from others, then you need extra effort, and extra has no limit. You have to put a hard labor. Time has gone very long. Thank you.